Hello and welcome to my video about the maximum velocity of an oscillator. So this is in my unit of Physics 20 called oscillatory motion. So what is the maximum velocity of a spring system shown below when pulled out to a distance of x before being let go to oscillate? Now this is such a common question that yes, you can use this method to solve it, but it's so common that we actually are going to give you this formula on the formula sheet. So I'm going to break it down, show you where the formula comes from, because it's actually nothing crazy, it's actually nothing new. This is actually coming from the energy unit. So if you remember in conservation of energy, we said mechanical energy at the beginning equals mechanical energy at the end. And so the initial potential energy, which is the, let's just say this is the max distance, it has to do with the max position, okay, whatever that is, will somehow give you your maximum velocity, which will be your maximum kinetic energy. So if you use the two different formulas for that, so the spring potential energy on the left and the kinetic potential kinetic energy on the right of the equal sign, then you can rearrange this and eventually solve for v squared. Now, personally, I think that I did too many steps at once, so I'm going to do a step to the side here, where basically I multiply by 2 on both sides, and so it cancels that 2 out. Then I'm going to move the mv squared to the left-hand side, just because we like to have the v on the left-hand side. And now I think it's fine to go to here. Okay, so now we're going to divide by m on both sides, then we square root on both sides. Then you can see that because this is squaring and it's a square root, the x can come out of the square root, and so this is our formula. Now in your formula sheet it'll say v equals a, which is amplitude, and then the square root of k over m. Amplitude is the same thing as your maximum position. So max position, okay, is your amplitude. Okay, that's a big concept. Okay, so let's keep that in mind and look at this, this spring down here. We've got the spring being pulled forward by some sort of maximum position. This is a smooth surface or a frictionless surface. Okay, but anyways, the spring is being pulled forward by some sort of maximum x, which is your amplitude, and then when it gets back to that position, it'll have your max velocity. Then it goes back and forth and back and forth, right? So it'll look something like that. Okay, so this is the formula from the formula sheet. Let's try it out on a couple different questions. So that's the formula, and these are the different explanations of the formula. So V max, A, K, and M. At the church picnic, there are many inflatable games. One such game is called the bungee run. The purpose of the game is to run as far as you can while the bungee pulls you backwards. When you slip, you'll be pulled in an elastic sense back until the bungee cord is loose. Assuming that you run as far as you can, then jump forward, your feet won't be touching the floor, therefore you will have 0 friction. You are that weight, and you're able to take 2.5 steps past the tight bungee cord. So 2.5 meters past the equilibrium point. As the bungee cord, with the spring constant of that, pulls you backwards, what is the fastest speed you will go? Okay, now I'll tell you right now that I played this game at a youth conference back when I was in high school, and it's a very fun game until you break your toe, because you're running and then you step on your toe as you're going, and it's this sponginess. So I broke my toe on one of these games, but the concept is there. So once it's tight, it's pulling you backwards. Okay, so if you can take 2.5 meters, 2.5 steps, we just made it 2.5 meters, past the tight position, then it'll pull you back with some sort of force. Now, if you're asking about the fastest speed you'll go, well, this is the formula. So we're looking for V max. We know the amplitude is 2.5 because that's the distance from the equilibrium point that we've gone. We know our own mass is 55 kilograms, and the spring constant is 68 newtons per meter. All right, so we're going to now plug this directly into our calculator. So we get 2.5 times the square root of, and then we have a fraction with 55 on top and 68 underneath. So we get the answer of 2.248. Now, we have 2 sig digs, so it's just 2.2 meters per second. All right, now your friend tries to beat your record distance and manages to go further than you all the way to 3 meters. If the friend maxed out at 2.5 meters per second using slow motion to record it, how heavy is your friend? So now you're going to weigh your friend given his speed and amplitude. So here we've got it. We're going to rearrange to solve for your friend's weight. So it's going to be V over A equals square root of M over K. Then we're going to square both sides, so V squared over A squared equals M over K. Then we're going to move the K over, so it's K V squared over A squared equals M. All right, since we have a bunch of different pieces of information, including 68 for the K value, including 2.5 for the speed, and 3 meters for the amplitude, we can again plug them directly in our calculator. So we get 68 times 2.5 squared over 3 squared. So your friend weighs 47.2 kilograms. Now, with sig digs, it should be 47 kilograms. So I hope this video helps you better understand the maximum velocity of an oscillating spring. Hope this video helps, and good luck.